Good morning, everybody. Today is Monday, October 11th. We're going to be in lesson 2.1 today on plate motion. And we're just kind of be talking about what's going on underneath Earth's plates. So the warm-up today is a message from Dr. Moraga. And he says, thank you for your work determining that today Mesosaurus fossils are found on two different plates, and these plates have a plate boundary between them. Remember, in chapter 1, we have 4 key concepts, and they are that Earth's outer layer is made of hard solid rock. It is divided into sections called plates, and that geologists look for patterns in landforms and geologic events in order to better understand Earth, and also that the plates of Earth's outer layer, move. So now that we have all that, Dr. Moraga is going to ask us to investigate another question, and that is, how did the South American plate and African plate move? So you're just going to answer that question in the warm-up. We talked about that in class. It leads to the chapter 2 question, how did the South American plate and African plate move? And in class we were talking about, well, they moved apart, or they moved away from each other, so that's divergent. But I think what you really need to understand is this question is not just asking a very simple, how did they move? They moved divergently. That's not what it's asking. It's asking, ultimately, how are those plates moving, or what is causing the plates to move? How is that happening? So we're going to be looking in activity number 2, and we are looking at how Earth's plates move. We'll be working in the sim, but I want to draw your attention to the cross section of the sim before we get started. So underneath that, we've already referenced this. In the cross section, you can see the gray outer layer of Earth's crust, and then underneath that is orange, and that's called the mantle. And of course, this view is when you just first go into the sim, it just automatically shows you that cross section. In the sim, you're going to slide that mantle bar from soft solid over to hard solid, or kind of in between. You guys get to choose kind of how you want to do that. And then go ahead and run and see if there is any movement, or what the movement is, or what's the difference in the movement between convergent and divergent plate boundaries. So if I were you, I would double check, make sure that you understand the characteristics of a solid. Okay. Looking underneath here, we see that the mantle is either a hard solid, and that's gray, or if it's a soft solid. And so I need to know that you guys understand what is a characteristic, or what are the characteristics of a solid. Well, first of all, a solid has mass and it has volume. Mass, the definition of mass is the number of atoms that make up an object. So each one of these, in this diagram, each one of those little small circles represents one molecule, or one atom. And volume is the amount of space that something takes up. So a characteristic of a solid is it has mass and it has volume. Also, the molecules are really, really close to each other. So see how tightly packed they are? And that makes the solid hold its own shape. So it doesn't take the shape of its container. We talked in class about some examples of hard solids, and we said, okay, our tables are hard solid, the chairs are hard solids, glasses, the goggles, like the ceiling, all kinds of things. We understand examples of hard solids. The idea of a soft solid might be a little bit foreign to you, or you might kind of scratch your head and wonder for a second. But we talked about some examples that you guys are really familiar with. Peanut butter is one. So peanut butter has mass and volume. Its atoms are close together, not as close together as a hard solid, but they are close together, and it really does hold its own shape. So if I took that scoop of peanut butter out and I laid it on the table, it's not going to ooze or slide and get flat. It's going to just stay a sticky lump on the table. So it does hold its shape. Another example is clay. Another example is chewing gum. All of these are examples of soft solids. So going back to your sim, you're going to make the mantle in the sim softer or harder and observe how the plates move after you make the change. There is some data tables, a couple data tables in activity 2 on screen 1, and then again, I think in screen 2. And so go ahead and run that simulation, pause the video, run it, fill out that table. I will be looking at those to make sure that you are doing them and understanding them correctly. So I'm looking for understanding there. We took a little bit of time to talk about what we observed, but I just want you to pause the video right now and make your own observations, okay? Go ahead and do that. Okay, so make sure, please, that you hand in your activity screen 1. You hand in those tables that you filled in so that I can see what you wrote. And we talked about the mantle vocabulary. It's the layer of soft, solid rock underneath Earth's plates. And hopefully what you saw was the harder the mantle, the less likely the plates are to move. In other words, the plates are only going to move if the mantle is soft, solid. They don't move any other way. Okay, that's good to know. Put that in our back pocket. The next activity we did is I had 2 items for the kids. I had a hard, solid cube made out of plastic, and then I had this substance called silly putty. And I don't know if you've ever messed around with silly putty before. It's a little firmer than Play-Doh. It's kind of plastic. You can pull it. It's ductile, meaning it can be pulled into kind of a thread. If you pull it slowly, it stretches, but if you pull it really hard and separate it fast, it snaps and breaks apart. And so I just gave the kids a couple minutes just to observe how they behave differently. I had them manipulate them, try and squeeze them, try and make them go flat, try and pull them in a wire or in a thread. And of course, the only one that was able to do that was a silly putty. Even though they both have mass, they both have volume, they both hold their shape, they're both solids, they behave differently because one is a hard and one is a soft solid. Okay, so again, they had this table. Now, because you were not here, I do not expect you to complete this table, so you can go ahead and skip that. And so then we just had a class discussion about how we think the soft, solid mantle allows the plates above it to move. And for right now, we don't have an answer. I just kind of wanted to have the kids just sort of start to think about the reason why it moves. We know it does. We know the only way the plates will move is if they're above a soft, solid rock, the mantle. But what's actually causing that motion? What's moving the plate? We know it's like hovering over that soft mantle, but where is the force coming from that's moving the plate in one direction or the next? And those are some questions we're going to answer in upcoming lessons. So we've got a key concept number 5. Earth's plates move on top of a soft, solid layer of rock called the mantle. Go ahead and pause this video, get out your key concept graphic organizer, and make sure that you have key concept number 5 written down. Okay, and lastly, we had an exit ticket. I would like you to finish this just because I want to know that you understand what we did, and especially since you were gone, if there's any misconceptions or misunderstandings, it's really important that we catch those right now and clarify. So if you go into activity number 5, it's called the homework, and it's just asking a question. It's giving you a scenario of being on a specific planet, a different planet, I guess. It describes the mantle there. And the question is, do you think plate motion would take place on that planet? Why or why not? And go ahead and use the words in the word bank to answer the question. And then that way I will be able to determine whether or not you understand key concept number 5 well enough to apply it to a different scenario. Okay? Let me know when you are finished with everything so I can go in and grade it for you. And hopefully I'll see you tomorrow.